It is December of 1938. The nuclear fission process had just been discovered in Nazi Germany by radiochemists Otto Hahn and Fritz Strassmann. In addition to an immediate release of energy, this process resulted in the emission of neutrons that would collide with other atoms, resulting in a chain reaction associated with an enormous potential for generating energy. With the discovery of nuclear fission and the beginning of World War II, it was only a matter of time before nations would consider its potential for weaponization. Supported by eminent scientists who fled the war in Europe, the US initiated a military-led covert initiative to develop the world's first nuclear weapon. This became known as the Manhattan Project. Join me as we explore this frontier in history, a project involving many of the greatest minds of the time bent on developing the most fearsome weapon ever known to man. In 1939, after becoming acquainted with the potential danger atomic energy could pose, physicists around the world, especially émigrés escaping fascist regimes in Europe, warned government officials on the matter. A letter signed by Albert Einstein warned President Franklin D. Roosevelt that it may become possible to set up a nuclear chain reaction in a large mass of uranium, and that extremely powerful bombs of a new type may thus be constructed. Uranium, as Einstein mentioned in his letter, was the 92nd element on the periodic table. It was a radioactive substance, and one of its isotopes, uranium-235, was capable to undergo nuclear fission. Roosevelt responded to Einstein's letter by initiating a government committee to fund early uranium research and design an atomic reactor that could potentially provide an alternate path to the development of an atomic bomb based on elements other than uranium. In early 1940, $6,000 was committed to start research under the National Bureau of Standards. In 1941, the project was put under the direction of the Office of Scientific Research and Development. Scientists argued that reorganization and acceleration of atomic research was necessary if the US joined the war. 1 month following the surprise Japanese attack on Pearl Harbor, President Roosevelt approved the construction of an atomic bomb. Following the United States' entry into World War II, control of the project was ceded from the Office of Scientific Research and Development to the War Department, given the resources needed to construct plants and facilities to be used in the research. Management fell initially to Colonel James C. Marshall of the U.S. Army Corps of Engineers. Marshall established offices at the Atlantic Division headquarters on Broadway in New York City, which gave rise to the name Manhattan Engineer District, or MED for short. The chief task of the MED was to produce sufficient quantities of enriched uranium to produce an atomic bomb. In September of 1942, Brigadier General Leslie Groves was placed in charge of all Army activities related to the project. Subsequently, the code name for the initiative became known as the Manhattan Project. To be useful, the fissile uranium-235 had to be separated from the non-fissile uranium-238. Two primary means of physical separation were investigated. These methods included the electromagnetic and gaseous diffusion methods. Both of these methods required large and complex facilities as well as vast amounts of energy. Due to doubts regarding the viability of these methods, a third method, liquid thermal diffusion, was also implemented to supplement production. Groves selected a 70-square-mile tract of land near Oak Ridge, Tennessee, as the location to build the Y-12 electromagnetic separation site, K-25 gaseous diffusion site, as well as the S-50 liquid thermal diffusion plant to produce the isotope uranium-235. Glenn T. Seaborg, an educator at the University of California, Berkeley, conducted experiments which led to the discovery of the 94th element, plutonium. Seaborg later determined that one isotope, plutonium-239, was nearly 2 times more fissionable than uranium-235. This opened yet another path to the production of atomic weapons, especially because this isotope of plutonium could be created from the non-fissile uranium-238. Before mass production of plutonium-239 could begin, It first had to be shown that the isotope could be produced from a uranium-fueled reactor and separated into suitable amounts. The design for a full-scale plutonium reactor began at the Metallurgical Laboratory, or METLab, of the University of Chicago in June of 1942. At the same time, a group of scientists led by Italian physicist Enrico Fermi built the world's first artificial nuclear reactor, Chicago Pile 1. Amassing data gathered from METLab and Chicago Pile 1, Groves selected a site near Pasco, Washington, which would become the Hanford Engineer Works, to build the full-scale production reactors required to produce a sufficient amount of plutonium-239. One of these reactors, the B reactor, became operational in late 1944. In 1942, Leslie Groves commissioned a laboratory to be built at Los Alamos under the direction of a physicist from UC Berkeley, Dr. J.R. Oppenheimer, with the purpose of centralizing efforts to purify fissionable material and craft it into the shapes needed. There was also a need to develop a shell in which the explosive could be delivered by airplane, as well as a fuse that could start the ignition process. By 1944, it had been agreed upon that a gun-type design would be used for an uranium bomb and a more complicated implosion method for a plutonium bomb. By the summer of 1945, the plutonium B reactor facility at Hanford Works had produced a sufficient amount of plutonium to support a nuclear explosion, and weapon development and design had proceeded far enough to allow for scheduling a field test. By this point, the $6,000 authorized for the Manhattan Project had grown to $2 billion. Given the ability of sufficient weapons-grade uranium to craft one bomb and high confidence in the gun-type design, development of a single uranium bomb was initiated. The bulk of the device was shipped to the West Coast without its design having been fully tested. However, researchers believed that a test of a plutonium bomb was crucial. Thus, the plutonium produced by the B reactor was created into a plutonium bomb, and on July 16, 1945, at Alamogordo Air Base, the first atomic bomb in history was detonated as part of the Trinity test. The explosion was equivalent to 21 kilotons of TNT. After developing mankind's most dreadful weapon, Dr. J.R. Oppenheimer stated, "Now I am become death, the destroyer of worlds." President Harry S. Truman was sworn into office after Roosevelt's sudden death in Warm Springs, Georgia in April 1945. Receiving word of the successful Trinity test, President Truman felt that the bomb could end the war without the USSR's assistance. In the morning of August 6, 1945, a B-29 bomber named Enola Gay took off from Tinian Island with the uranium bomb Little Boy in tow. Its destination was the Japanese city of Hiroshima, which had roughly 300,000 civilians, and it was a vital military center. At approximately 8:15 a.m., Enola Gay released Little Boy over the city of Hiroshima. The pilot, Paul Tibbets, recalled that the city was hidden by that awful cloud, boiling up, mushrooming, terrible and incredibly tall. The explosion yielded the equivalent of 15 kilotons of TNT and killed 70,000 people from the initial blast. This excluded the large number of deaths caused by radioactive fallout over the next several years. 3 days after the bombing of Hiroshima on August 9, 1945, a B-29 bomber named Boxcar was equipped with a plutonium bomb called Fat Man and took off from Tinian Island toward its intended target, Kokura Arsenal. Due to a series of issues, the B-29 decided to release the bomb upon its secondary target, the city of Nagasaki. At 11:02 a.m., Fat Man was dropped over the city. The force of the explosion was estimated at 21 kilotons of TNT, 6 kilotons more than Little Boy. The bombings of Hiroshima and Nagasaki brought the surrender of Japan and an end to World War II. Reports and pictures of the devastation were a cause for great concern and spurred a race among developed nations for the acquisition of nuclear arms. Although the United States was the first country to successfully detonate a nuclear weapon, many others soon followed, including the Soviet Union in 1949, the United Kingdom in 1952, France in 1960, and China in 1964. As the availability of nuclear weapons grew, new designs yielded bombs that were orders of magnitude more destructive than those dropped on Japan. The testing of nuclear weapons also became a concern for human health and the health of ecosystems. In April of 1950, Paul Nitze of the U.S. State Department's Policy Planning Office presented a report to the President, the National Security Council Paper 68, promoting the development of tactical nuclear weapons to combat Soviet expansionism. Tensions grew among nations and climaxed during the Cold War between the US and the USSR. In the modern era, nuclear weapons have come to play a deterrent role in countries' military programs. Once Pandora's box had been opened, it could never be closed again. The Manhattan Project was an important frontier in history, as after this time the nature of warfare and international relations were forevermore changed.